now what we're going to do is we're going to talk about Facebook ads a little bit. This is a very small group, and perhaps some other folks will join, but I really want this to be a bit of an interactive session. Okay, there we've got someone else. Halima, welcome. Oh, I hope I pronounced that right. So we've got the scope for this to be a pretty interactive session. What I would recommend is if there's a question or a comment that you have as I'm working and talking, drop it in the chat. And Lauren, who is sitting next to me, will. Thanks, Lauren. Lauren is sitting right there. She will get that information to me, and we'll figure out how we should deal with what you've got going on. So we're here today to talk about a specific subset of data that is offered by Facebook through their API. And there are a couple reasons why. We're talking about specifically ads data, okay? Ads data that is published by Facebook. And one of the reasons is it's really interesting data. There's a lot of interesting and useful applications, not only applications for people in who perhaps are interested in the issues themselves, but also for people who are thinking about the ways that they may use Facebook in their own work for communications or for marketing. This is kind of the most basic entry point to interacting with Facebook as a developer. The actual API that we're going to interact with is a public API. You only need a basic secret key from Facebook in order to access this API. It's not something where we're going to have to jump through a lot of hoops. So for those reasons, I thought it was a good candidate, and it's kind of interesting data. So the first thing that you have to do is register a Facebook account. In order to interact with the Facebook API, the basic requirement is a Facebook account. So if you don't have one, now is a great time to create one while I'm chatting, facebook.com. And once you've done that, you're going to need to hit a website. Let's just pull that up. You're going to need to hit developers.facebook.com. Okay, this is your starting point. And on the developers page, okay, what you want to do is you want to click My Apps. Okay, now we already have an app. But we're going to create a new one just for today, just so that we can all do this together. So once you've registered with a Facebook account, you can log in to developers.facebook.com. Okay, you can see that my identity is identified up there in the upper right-hand corner, and click Create App. Okay, so we are first asked, what do you want your app to do? Okay. And the first thing that you'll see once you do that is this list of possible use cases. Our use case is other. We don't need people to log in with their Facebook account to use this app. And we do not need any user data. We only need public data. So we can make our lives a lot easier by choosing other. Okay. Now we have to choose an app type, okay? And a good way to go forward if you're just going to play with the API is use the academic research app type. Oh, nope, that's right. I tried this the last time, and it only works if you actually have an account at an academic institution. So we are going to have to try something else, and we are just going to say none. All right, and add an app name. Backforge is cool. Okay, great. We don't need a business account or anything like that, so we can just go ahead and click Create App. All right, sure thing. Okay. No, we don't want to do that. Okay. I swear I know my own Facebook password. There we go.
I don't know mine, so it's okay.
Okay.
You just hit Create App when it did that? Oh, okay.
That's right. So now we're here on the developers page. Okay. But the important thing is that we've created our app, and you can see in the upper left here in that drop down box, that's our app name. Okay. We've got our app name and our app ID. Now that we've got this, you can check out the, I'm just going to pop it open and suggest that you take a look at, click on tools. Oops, sorry. Click on tools. Okay. All right, where is it? Well, I'm just going to type it. The API Explorer, there's the URL. It's developers.facebook.com/tools/explorer. This is a tool that allows you to do a couple things that we really need to do today. On the right-hand side, you will see a little text box that's labeled access token. Okay, this is actually the token that we're going to use in our code. So what you want to do is generate an access token. Okay, there you got a new one. And I'm going to save you some time. Okay, what will happen here after this session? So see, this is how you guys know I'm looking out for you, because this would have all happened after I was gone forever. You want to navigate to developers.facebook.com/tools/debug/access token. Okay, do that in another tab, because what you're going to, go ahead, Steve.
I hit generate access token, and it told me the feature is unavailable for this app. And
is that right?
Yeah, so now I've developed other apps before. So is it messing? Because I already have some tokens.
Are you sure you're in the right app?
Yeah. Oh, am I in the right app? I'm in my, I'd say call it test something, whatever app. Should I? Hey, wait a minute.
That should be good. Yeah.
I'm testing stuff. So I'm in testing stuff.
Yeah.
You can go to graphic tools where the Graph API Explorer.
Yeah.
And then I see generate access token. And I'm going to hit generate. And it tells me it's unavailable. Interesting.
Okay. So let's take a look here. I'm going to try the same thing.
Mm-hmm.
Okay. So there we go. I had to select my app in the drop down on the right hand side.
On the right hand side. Okay.
So make sure you're in the right.
Got it.
Yeah. Okay.
Because it defaulted to another app. I thought it was just listing my old apps. Now I'm down in it. And you're correct.
Good stuff. Okay. So the default API query is me. Okay. So that gets you information about yourself. This is pretty much the hello world of API queries to Facebook. So basically, that query establishes that our access token works. We have connection to the API. We can get data back. So you can use this Graph Explorer for a lot of use cases. If what you're looking to do is play with this data, you can use the Graph Explorer, the API Explorer, to get some data and then export it into your tool of choice, Excel or whatnot, and then work from there. That's a possibility. That's something that you can do. But we're gonna go a little deeper. Okay. So you're gonna get JSON back. Having said that, so there are a few little things that you would have to do to turn that into a usable spreadsheet. There are lots of online tools for that, but there is a gotcha. So what I'll do is I'm going to get started on the actual app here in Visual Studio Code. So this is the editor I choose. I like Visual Studio Code. It gives me a lot of features that I like as a developer. There is no reason that you can't do this with some other tool. We're going to be using a couple of other tools tonight besides Visual Studio. We're also going to be using Docker. Okay. Anybody here not at all familiar with Docker? Okay. All right, Steve. So Docker is, in concept, it's not that dissimilar to virtualization. Okay, in the effect on the end user, it's essentially the same. It's a little bit different under the hood. It's not actually creating virtual machines. They are more like Linux sort of chroot jails than they are virtual machines. Those details don't matter. The idea is that with Docker, what we have is a widely used way to build up services and servers. And what's valuable about that is that just about every open source project out there has Docker specifications to create Docker images that you can then create containers with for whatever software that you want to use. And so the advantage in this case for this type of work, and what we're doing here is the type of exploratory ETL work that that a lot of people, like a lot of folks who do an analysis, would be doing on a daily basis. So for this kind of work, what you're going to find is, and Python is my tool of choice for ETL, but what you're going to find is that you will have a need for different modules, different software modules for Python. You will have a need potentially to utilize different versions of the language or different versions of different modules at different times. And for anybody who has enough gray hair to remember what it was like to develop software back in 20 years ago, 15 years ago, there was a lot of work done just to create that infrastructure that you needed to get to work. Well, the beautiful thing about Docker is we define our infrastructure with code, and in a few lines, we've got what we need. So this is not a Docker tutorial, and I am not a Docker expert. I'm a person who uses Docker to solve problems, so I want you to take what you're going to see here in sort of that light. We are going to work together and use Docker. If you want to learn about Docker, I strongly suggest that you check out the official Docker documentation. They have some great tutorials to get you started. But if you're interested in using it the way I use it, then this may be good enough. Okay, so we're going to start with a new file. Okay, we're going to start with a new text file. I don't like creating them that way, actually. Sorry. Let's do it this way. And that file is called Dockerfile. Okay. And the Dockerfile is the tool that we use to tell the Docker engine where to get the image and what to do with that image when you create a container from it. The container is what we actually interact with and run code. Okay. So we drop in a from line. Okay. So what is this line doing? It is identifying our image source. So our source is Python. We want the official Python image. Then after the colon, what you're seeing there are some tags, some decorators for that image identifier, and that's identifying exactly what we want. So we want Python 3.8. And we want it running on Buster, which, if I'm not mistaken, is Debian. So we want it running on Debian. I think that's Debian 10. If I'm wrong and anybody knows, let me know. Okay, we need to move our code into that Docker image. So we'll need a directory. Okay, so our working directory for that Docker image is going to be /app. Okay. And we need, I thought I turned off Copilot, but it is completely right about what I need next. Okay. And what we're doing here is we're using the copy directive. And what we're doing is we're telling Docker to copy a file from the source being the working directory that we're in, to the destination being the working directory in the app that we just identified. Okay. And what is in requirements.txt? What is requirements.txt? Well, that is a special file that Python needs. Okay. And Python needs requirements.txt to identify the modules that we're going to install. And there is the command that we'll use to run inside of our container, the pip installer to install our requirements. So, and then the last thing that we do in our Docker file is we copy everything from the current directory into the destination directory. So these These two commands are redundant. You don't have to have both. Like you could just copy everything and then run pip. I like it this way for clarity. Okay, that's our requirements.txt. So Docker, if all you want to do is create one container for development like this, I'm basically just creating a Python machine that I can interact with. You don't need to go any further, okay? When you get into orchestrating multiple images and containers to create a whole virtual infrastructure with different services on different machines, you want to use Docker Compose. We don't need Docker Compose here. I'm just telling you that it exists and you can kind of think about it on your own. That would be the next level. But for the purposes of what we're doing, we just need something quick to get ourselves oriented and get noodling. This will work. Okay, but this copy command isn't going to work until we have a requirements.txt file. So in requirements.txt, sorry, that's lowercase r. In requirements.txt, basically what you have to do is identify each of the modules that you are going to use that are not built-in Python modules. So what external modules are you going to use? And what this will do is make sure that every time you start up this container, that you are going to land with a dev environment that has all your requirements in it ready to go. So our requirements are, we need the request module. Okay, we're going to be looking at that. That's the way that we connect to HTTP servers. Okay, PEDAL is my ETL tool of choice in Python. It is a great little tool. And if you remember, I talked a little bit about why it might be difficult to move directly from the Graph Explorer to Excel. The reason for that is that there are some nested entities in the JSON. So we're going to look at that. But when we get to dealing with those problems in code, we're going to use PEDAL to solve them. And finally, who doesn't like an image, a graph, a chart? And we use matplotlib to create charts because it works and it's easy. Okay, so now we have specified enough stuff. We have specified enough stuff that, and this is the beautiful thing about Visual Studio Code, we've defined our container. We can now reopen Visual Studio Code in the container and develop directly in the container, unless the Docker daemon's not running. So let's just make sure that our services are running. So just since we're talking about it, this is what the Docker desktop dashboard looks like. There's the containers that we've got in use, or the images, sorry. Images are what you get from the internet that get turned into containers that run on your machine. Okay, so now that Docker's running, we should get a better result from reopen in container. You don't need anything extra. Just do your thing. Okay. And so now we can watch the log here. And what we're watching is Docker is in setting up our, sure, go for it. Docker is setting up our image. Okay, so now we're ready to go. And now if you look down here in the left, the sort of bottom left, you can see we're editing on the dev container. So now we're, even though I'm running OS 10, we've got a Linux environment. You can see the output here from the container creation process, and you can also add another terminal, and then you've got direct access to the container as well, right there. Fun stuff. Okay, now let's get into the actual script. Okay. Okay, so we are going to create a new file, and we are going to call it getfbads.py. Okay. All right. So we gave this file the py extension because it is a Python script. Visual Studio understood what we're doing. I've got the Python extension installed. or we will have to install the Python extension here. One thing that is a little annoying about working with dev containers is that you have to reinstall the modules, the Visual Studio Code modules that you want to use in the container. But we're going to do that with the Python module. It's worth it because we get debugging capabilities if we add the Python module. Okay, back to our script. So the first thing, who here has experience writing Python? Okay, so we got one. Devin and Halima, do you folks have experience with Python?
Yes, I do.
Okay, great. All right, we've got one newbie, one unknown, and two experienced Python users. Okay, so I'll try to pitch it so that everybody gets something out of it. The top of our Python script, typically this is where folks are going to include the modules that are required. So including the list of modules that you need in requirements.txt is not sufficient. Python still doesn't know that you want to use those modules. All we've done is tell pip we need them installed. So to tell Python that we actually want to use them in this script, we're going to drop in some import statements here. Let's walk through these. The requests module and the pedal module, okay, and matplotlib should all look familiar to you because those were the three external modules that we required in requirements.txt. We also have some built-in modules that we're using. We're using the JSON module because we're going to get JSON back from the API. We're using the collections module so that we can get the ordered dictionary data type. That's a special type of dictionary. Just what it says on the tin. It has some of the attributes of a list or an array and some of the attributes of a dictionary. That is something that we'll need for a very specific piece of our interactions with Petal. Matplotlib to draw stuff, and TextWrap because we want our graphs to look nice, although that's a piece that we might have to work on. Okay, so what I thought would be interesting would be for us to take a look at who is spending money on the top three issues facing Canadians. Who is spending money and how much are they spending on Facebook ads to talk to Canadians about these issues, okay? So this, according to a national survey of Canadians done by Abacus Data last month, these rising cost of living, affordability and accessibility of housing, and healthcare are 1, 2, and 3. It's fun to do this sort of thing when you're working with GitHub Copilot, by the way, because the AI will hallucinate facts for you. Kept telling me the wrong thing was like the first, second, and third issue facing Canadians. Is quite interesting. It's easy to forget that you're dealing with an LLM when you deal with Copilot because usually it just spits code at you, but every once in a while you get some of the fun stuff. Okay, so we are going to need to make a request to the API, right? And the request that we need to make, let's just hit our API Explorer. Okay, did I close that window? Looks like I did, okay. There we go. Here's our Graph API Explorer. So let's start here. Ads archive. Okay, that's who we want to talk to. We're constructing the URL for our API right now. And then we're going to need to supply some parameters to this request to the ads archive. There's a few parameters we have to supply. We need to identify the fields, okay? The fields that we are going to get back. So we want a list of fields from the API. And that would be, just for fun, there we go. Okay, So we've got how much is spent, who are the target ages, who's the target gender, what's the name of the page that posted the ad, how many impressions did it get? Okay. Is that enough? It is not. Instead of a D. Okay. Well, that's interesting. Okay. Let's try. Oh, we don't need the access token because it's already provided for us there. Add reached countries. Okay. For that, we would want, you know what? I think this is my problem right here. There we go. And add reached countries, we want Canada. There we go. Okay. Okay. Is that enough? No, we need search terms and search page IDs. We need search terms or search page IDs. And we're looking for search terms. Okay, so we need search terms. Search terms equals, okay, and you'll notice that both the reached countries and search terms are bracketed with square brackets. That's an array literal. So what that means is that you are not limited in this API call to one country or to one set of search terms. You could actually include a comma-separated list of search terms and countries if you wanted to. We're going to keep it simple. So let's just make cost of living the search terms, okay, and hit submit. Okay, look at that. We got data back. Let's look at our data. So we have a JSON object here. Okay, so there is a data key, and that data key contains an array, and it looks like that's all the return values of our data. Okay, let's scroll to the bottom though. So besides that array of data, we also get a paging key, which is very important. Okay, the API does not give you back all the data you asked for at once. It gives you a page, a chunk. Okay, so we just got a chunk, and at the bottom of our chunk, it identifies for us the URL for the next chunk. Okay, so what we have to do in our script is not just grab that first page of data. We have to loop through all the data until there is no next, until there is no more next, and then we're done. Okay. But I think we can do a few more things here, because right now what we're getting is we are getting the data about every page that has ever spent money on ads related to cost of living in Canada. We need to narrow that down a little bit more. Okay. One other thing that we can specify that I think is important is ad active status. Do you want to see ads that are currently in play, or do you want to see ads that are finished, canceled, perhaps, right? All of those different statuses. For our purposes, I think we want all. Okay, we want all of the statuses. But if, for example, you were doing a piece of research and you wanted to check day by day what was being spent each day on a particular issue, you might want to have a different ad status. You may only want to see the active ads that day. Okay, and we can also specify, we can put some boundaries around the delivery date. So these parameters are add delivery date min, okay? And here we just specify a date in year, month, day format. So starting at the beginning of this year, and add delivery date max equals, let's make it today, 2023-09-28, okay? What I'm going to do is I'm going to drop this in the chat just in case any of you are typing it and potentially encountering problems. Okay. Okay. This is good. I want to talk to you guys about this. But let me drop something in the chat for you first. Okay. So there's the query for the Explorer, just in case you were having trouble typing it or you couldn't quite see my screen. There's everything there. Okay. Yes, Devin, go ahead.
I'm getting an OAuth exception when I
just like this one.
No, mine is slightly different.
Okay.
Authorization and login needed. To access the API, you'll need to follow these steps at link to the API.
Okay, so Devin, do you have a Facebook account?
Yes.
Did you register as a developer?
Yep.
Okay, did you create an app?
Yep.
Is the selected app in the right-hand side the right one?
Yep.
Huh. Okay. You kind of got me stumped. What I would suggest is just walk through those steps again. Make sure you haven't missed anything. Do you get, before you do that, on the API Explorer page, can you get the me query? Can you get a response back to the default me query?
Yes, I do.
Ah, okay. So that is really interesting. I'm not sure, but let's try. I'm going to show you something right now, and let's try this and see if this might have something to do with it. Because what's happening in my world is that I think this token, I'm going to go over to the Access Token Debugger. Okay, developers.facebook.com/tool/debug/access token. Sorry. I dropped that guy in there. And okay, it expires in about an hour. It should be good, but I'm extending it. Okay, so when you get a token on that Explorer page, it's only good for an hour or so. But if you click extend access token and then apparently re-enter your Facebook password, now you get a new token that you can use for a month. So I'm going to take that token away, okay, and we're going to use that in our code. And Devin, I wouldn't worry too much about not being able to get into the debugger. The key is going to be using your app to access the API through your Python script. So if you're able to get a response to that me query, but you're not able to get a response to this one, I'm hoping that we won't see that problem in the script, but let's find out together, I guess. Okay, so if you remember where we were, we had identified the top 3 issues facing Canadians today, and now I think you can kind of guess maybe what we want to do next. That list of parameters that we just talked through, whoops, we're going to turn those all into variables so that we can control them. Okay, so in Python, especially if you're just writing a quick one-off script, you do not have to declare variables. Okay, you don't have to declare their type. We don't have to worry about all of that fanciness. In fact, we can just name the variable and assign it right away. And so that's what we're going to do here. We have identified all of those parameters from our URL. Okay, which gives us then the next step would be we want to create that URL, right? Let's do that. Okay, so this is just too much to type. So I've copied and pasted it. And what we've done is we're using an F string, okay? What an F string does is it allows us to interpolate variables directly into our output string without having to do. Anybody who's maybe a little bit long in the tooth will remember how we used to have to interpolate variables into strings with closing quotes, you know, some kind of concatenation operator, variable, concatenation operator, open your quotes, get back to work. We don't have to do that with F strings. They're very nice and clean. It's nice. So there is a corresponding item here for each of our variables that contains a parameter. So now when we want to query the API, we can just come back up here and make changes to our parameters without having to futz with the URL itself. Okay. Everybody with me so far? Okay. Seeing no objections. So let's now actually do the thing where we connect to the API. We're going to need an empty array. Okay. What my left square bracket key is conking out on me. This is not good. Okay. We need an empty array to hold our output data. And remember, I said we had to loop through the pages of our data in order to get everything, because we're only going to get one page at a time. Okay. So I like to employ a while loop pattern for this sort of thing. Probably just because I'm old and I like doing things the old school way when I can. So we're going to create a variable that contains the value true, and that's going to be our flag for our while loop. Okay. And so while flag is true, what are we going to do while flag is true? We are going to use the request module to talk to Facebook. Okay. So that R is going to be our variable that holds the request. Requests.get URL. Okay. So URL is the variable that contains the interpolated URL string with all of the parameters that we wanted in there. And we are using the get method of the request module to tell it to get that URL. And whatever you get back, stuff it into R. Okay. So R is going to contain the response to our request. The response object contains a whole bunch of different stuff. This is not, we're not doing a tutorial about the request module. So I just say to you that there is more to it than this. But for us, what we need is the text from the response. Okay. So our add data is going to be, okay. And what are we doing here? We are loading a string. We are loading a JSON string into Python objects. So what JSON, the JSON loads method will do is it will take that text we got back from the API and it's going to turn it into a Python data structure that we can interact with and manipulate. Okay, so that we don't have to deal with that complexity ourselves. Okay. So now we've got data in Python's structure. So we're ready to work with it. And we've got that lovely output data array. It's sitting there empty. Okay. What we want to do is we want to add the data that we just got to the output data array. But this is really important. Okay. This is an important character that I just typed. Okay. So what we're doing here is we are appending to the array. If you happen to visit last month and saw last month's session, you are going to realize right now that I must have just learned this last month because I did not know how to flatten a Python array until I wrote code to do it for last month's tutorial. And somebody was kind enough to let me know that there's actually built-in functionality to do that. You don't need to write your own code. I love learning things like that. So you can use that operator, it's not the append operator. Anyway, you can use the increment operator to append to a Python array. And that's what we're going to do there. So every time we go through a page, the new array gets added onto the end. It's not an array of arrays. We don't want that. We don't want we don't want two-dimensional array of arrays. We want a one-dimensional flat array where every element is at the same level. That's really important. If you skip that step, or you do it slightly differently, you're going to end up with a mess. You'll end up with an array of arrays that aren't going to work well for you. Okay. So one last thing to do in this loop, and that is stop it. Okay. We have to define the conditions that will allow us to flip that flag to false. Okay. So what we are going to do is we're going to use try catch or try except in Python. So a try block is a tool that we use to wrap a piece of code that we think could cause an exception, create an error, raise an error of some kind. Okay. And then we use the except block to catch the exception. In this case, what we're doing is we are writing a piece of code that we know will fail at least once in every loop. Okay. Remember that paging data at the bottom of the output from the API. That paging data, okay, if we want to look at it, that paging data, oh, where is that stuff now? Oh, we'll dig it up. That paging data, I lost it, that identifies the next, remember the URL of the next set of data in this collection. Okay, that's what we're asking for here. So we're trying that. But in the case when that entry does not exist, okay, when that entry does not exist, that is our condition for leaving this loop. Okay, so we're actually going to just rely on the fact that that we will not be able to assign URL to a value that doesn't exist, and we're going to use that to get out of our loop. Okay, so why don't we have typed long enough. Why don't we just stop there and see if this all works?
Run it.
Yeah. Okay. Takes a while. This is a good sign, though. Yeah, there we go. Okay,
This is
here's
a
our
holy
data.
crap moment. This is pretty good.
Okay. Here we go. We have a whole pile of data back from the API. All right, here we go. So there's some interesting stuff here to see. Remember, I mentioned that there's a couple levels. There's a couple levels of data here. That Facebook is careful not to give you the exact amount of money or the exact amount of impressions that any particular ad received. So we get a range. So here, this ad, the PC Party of Manitoba spent between $500 and $599. Okay. And they had between 40,000 and 44,999 impressions on the ad. We just have to accept that level of fuzz. That's the amount of fuzz that Facebook is going to give us. So what I decided to do, because I'm purely interested in a comparison, and I felt that the best way to do that, to get a fair comparison of everyone, is just to take the upper bound from everybody. I think it would be equivalent to take the lower bound, and equivalent, like sort of logically equivalent to take the lower bound, except that then you have many cases where the lower bound is 0. And we don't want that. I don't think that we want to aggregate 0 because it's the lower bound of a range. Like nobody spent 0 on an ad, right? So given that, and I don't want to synthesize an artificial value, right? An average is fake because you're averaging, you only have 2 numbers to average, right? So it's just the middle number. Taking a middle number from a range is just fake, right? So with limited information and the fact that we're just doing kind of a demo and exploring, we're just going to take the upper bound. Okay. In both cases, we'll just take the upper bound and use that. So what does that look like? Okay. So what we have right now is we have a situation where there is within each element in our array every element in an array contains a dictionary, and then that dictionary contains 2 dictionaries. This isn't going to work. What can work is an array of flat dictionaries, but this isn't going to work for our purposes. So we need to do some data transformation. Now, in our case, we have a couple options. We can do data transformation here on the JSON data, or our Python version of the JSON data, or we can do transformations in Petal. In this script, we're going to do both, partly to illustrate that we can do both. Okay, but you should be reasoning when you are working a data pipeline like this. You should be reasoning about what is the optimal place for me to do this operation on the data, right? And that may be different for different subsets of the work that you're doing. So just something to think about. Okay, so let's see. We want to transform this data. So let's do a new array. We're going to call it transformed data. Okay, we're going to just have a new empty array. And now let's work through. Okay, so we're going to use a different kind of loop here. We're going to use a for loop. Okay, a for loop is a little bit different. Instead of a while loop, because we actually don't know. When we start that while loop, we have no idea what the last page is going to be, right? So we have to just say, as long as this condition is true, just keep going. But in the for loop, we have the opportunity, because we know the upper bound. We know exactly the scope of the data that we want to work with. We can use a for loop instead. Okay. So what the syntax is a little different. And what we get here is we get to identify a name, and this name within the loop will be given to each individual instance. So every single dictionary in output data, okay, every one of these, just trying to find the right, anyway, there we go. Every one of these is going to be operated on in turn, one at a time, and in code, they will be referred to as add. So all the code that is in this level of indent inside the for loop is going to be operating on that one stanza or one dictionary of data at a time. For those who aren't familiar with Python, you may, and who have some experience with other programming languages, you may be wondering how any of what you see on the screen is working, because we don't have any semicolons to identify when a command line is finished, and we don't have any structure. We don't have any braces to structure our code to tell like where a block starts and where a block ends. Python creates blocks through indentation. The indentation of your code determines what block level it's running at. So our while loop, all the code that we need to run in our while loop must be at the next level of indentation beyond the first, okay? And then our try block here, creating another level of indentation, gets indented like that. It seems weird. And I learned on C style languages, braces and semicolons and all that stuff. And it was very jarring to me, but I do have to say that the average page of Python code is just easier to read than almost any other language.
Far more natural.
Because everyone structures their code the same way. You don't have a choice. Okay, so that was a lot of talking, but now let's do some coding. So what we're going to do here is we are taking those two sub dictionaries, those dictionaries in our dictionaries that we want to get rid of. We're going to replace them. We're going to replace them with a value from inside. So let's try this. First, we're going to say add spend is, and you got to be careful with this. We want a number. We're going to be operating on a number eventually, so we want to get a number out of this. And if you look down here in your output data, all of these numeric values that the API is giving us back have tick marks around them, because the API is giving them to us as a string, which is fine, no problem. But if we take them as a string, we're not going to be able to do math on them. And we want to be able to do math on these numbers. So we have to convert them into an integer. It's something that's easy to miss, right? It's just 3 little characters, but that is something that you could potentially bang your head against for a while. So we are going to take the upper bound value. Okay. So remember I said, remember I said that the dictionaries were two-dimensional. So we have to address that sub-dictionary. So add spend is a dictionary, and within that dictionary, there is a key upper bound. We want to replace add spend with the upper bound from the sub-dictionary. Okay, that's our optimal. Except that sometimes, there we go. Except that sometimes there is no upper bound. Okay, so sometimes there is only a lower bound. I found that out the first time I tried this. So in that case, if the upper bound doesn't exist, okay, then what's going to happen? You're going to get an error. And in that case, when we get that error, we are going to instead try using the lower bound. But what if there's no lower bound? Well, then we're pretty much stuck with 0. Okay. That's pretty much the only way I know how to do it. And then I am going to we are going to just add in the next one because we need to do the same thing for impressions. So in just in the spirit of don't repeat yourself, you look at the same code, the same exact code repeated like one line after the previous one. And it looks like an opportunity for optimization. I'm going to leave that as an exercise for the viewer, but that is something to think about. Like that looks to me like the kind of thing that you might want to only do that once. Okay, so now we've done in this loop. Oh no, that actually this whole block is wrong. There we go. Okay, and there. Now we're at the right indent levels. So what we want to do here is we want to execute all this code, then all this code, then append the new add because we have been operating directly on add. Okay, so we have been taking that one dictionary from the list and we're operating directly on it. We're directly changing it, and then we are appending it to a new list. Okay, that's what we're doing here. And so now what we should be able to do is run this script again, wait a few seconds, and what we should see is nothing because we have an error here. There we go. So I am printing the wrong variable. There we go. Okay, let's try that again. Okay, so now when you look at that output, what you may notice is that our spend and impressions are now flattened, right? Now we have a nice, simple output that that we can deal with in a lot of ways. So you could actually take this JSON and export it to CSV pretty easily and work with it in Excel. So we're at a point now where we've done the basic transformation. You might take this and just run with it. What I want to do now, though, is I now want to work, and I know we're running a little late. Like I know this was scheduled for an hour, but it looks like I've got a little more to say than an hour. It does not hurt my feelings if you have to leave, but if you want to stay, I'll be happy for you to do so. Okay, so next up, I want to actually create that petal table. All right, petal is a really great tool. I'm just going to jump to the petal website. Okay, yeah. Says, nope, that is something else. That is the Peel Elementary Teachers logo. No, no. We want the extract, transform, and load Petal. Petal is a fabulous, fabulous tool. And a lot of people will use pandas for data visualization and data work in Python. Pandas is an awesome tool, and I think it's really good. It's important to understand what each tool is good for, though. The main advantage that Petal has over pandas is that Petal is memory optimized for ETL operations, which means that no matter how big your data set is, the memory consumption of your ETL process will be more or less constant. Okay. And that's not the case with pandas. Pandas actually loads your whole data set into memory. And that can create a lot of problems with larger data sets or with operations that you expect to be repeatable. Petal is pretty well documented. I recommend you check out the docs, but we are going to just do the few things that we need to do with Petal to solve our problem today. So first thing that we need to do is get the data in there. So we'll create a table. We'll call it table. And we will use our Petal library. And then there are, and I'm just going to leave it there so that, can everybody on the call actually see the IntelliSense on that? Yes? Okay. So if you look at that IntelliSense list, what you're seeing is all the different ways that you can get data into Petal. You can get data from JSON, from an array, from a database, all different data sources. This is one of the values of Petal. But what we want to do is we want to get it from dictionaries, okay? Because that's what we've done. We loaded that JSON, okay? Now you could go direct from that JSON to Petal. You could do that. But in our case, we wanted to make some changes to our data before we started feeding it into Petal tables. So we did that. We turned it into Python objects. We did a bit of Python manipulation on it. And now we're going to drop the result of those manipulations into Petal. Okay. And so we need to identify the dictionaries. And that is transform data is our list of dictionaries. Okay. So now we've got a table. So let's see. First, let's just look at the table. There we go. Let's just look at what we get back from Petal.
Well, that's handy.
Yeah. So what you get back from Petal is a nice little preview of the first 5 records. Okay. There's the first 5 records of our table. Looks good. This is what we need. Okay. So that's great. So now we are able to observe our data and we know we're on the right track. Great. So now I want to check to see if there's any bad data in our table. Okay. So let's just create a new Petal table. Okay. We'll call it spend non-numeric. And we are going to use a Petal select. Okay. From table. Okay. And then we're going to use a Lambda function. Okay. That's right. There we go. There we go. So what we've done here, and this is really awesome, we have written a filter. Okay, we have written a filter. So what we do to do that is we write a Lambda function. Okay, and what the Lambda function does is it operates on the parameter, the record that you supply. Okay, so every record in the Petal table is passed through this function. Okay, and what we are doing here is we are finding all the rows that match the function where spend is neither an integer or a floating point. Okay, So we'll get a table. What we'll have here is we're going to see our base table, okay? And then here's the pedal table of non-numeric. Okay, no errors in our data. Great. We don't have any problem with non-numeric spends. We're going to assume that impressions are the same. You kind of get a sense of how you could do that code if you wanted to also check for impressions. And who knows, we might have to. So that's great. But now what we have is we have a record set that is showing us the details for each individual ad that fits our criteria. This is not what we want. Like, we want some aggregation and summary here. So what we're going to do now is we're going to group this data. We're going to aggregate this data and get a new table that just has the summary information that we want. How do we do that?
So by page name, is that what you're going to group by?
Yeah, I think so. That to me makes the most sense. So we are going to define our aggregation. Okay. So here's where that ordered dictionary comes into play. Okay. All right. And what we're doing now is we're defining the new columns. Okay. We're adding columns to our table. And these aggregations are the columns that are going to be added. So first, we have to define them. So table and operation, okay? Sum of spend and the sum of impressions, okay? Same thing. What's the column? What's the operation? Okay. So now let's create a pedal table. Okay, great.
It was very nice meeting you guys.
Yeah, cool. Thanks for coming, man. Hope to see you again.
I've like just moved to the area, but it's gonna find one of these groups. I used to do these sides over in Charleston, South Carolina.
Oh, okay, right on. We got any laptop stickers or anything?
Yeah.
Cook this guy up. He showed up in person. Okay. Thanks for coming.
Yeah, man. Thank you for hosting.
Yeah, no worries at all.
Oh, this is cool, man.
Good stuff. We do this stuff all the time. Okay, so aggregations. So we are going to use the aggregate method. Okay, like that.
All right, Doug, can I ask a question?
Sure.
So I see you're aggregating. You're aggregating what's supposed to be summed, but how do we exclude you want to exclude the ID, of course, because that's the unique ad identifier. So you don't want that in your aggregation at all, correct?
Yeah, so
basically,
that is, yeah, I'm so glad you mentioned that. So there's a couple things, okay? One, we never converted those ad IDs to a numeric value.
So there's a string.
They're just strings. We can't do math on them even if we want to. But the other thing that's happening here is that our definitions of our aggregations, we're identifying the column that we want to aggregate and then the operation. So what is going to happen here is in the call to pedal aggregate, okay, we have to tell it what table we want to operate on. And so this would be, this would be which table? Transformed, I believe.
Yep,
no, it's table. It's table that we want. Yeah. Okay. So we want to work on table. Okay.
Because you'll want to group on page name. So I'm just wondering how you're coding that.
Oh, you're right. You're right. That's right. So, okay, stay with me here. So in aggregate, so first we have to identify the key that we're going to aggregate on, right? So we're going to aggregate things on the page name. And then we get to do, there we go. And our aggregation is the aggregation that we just defined. Okay. And then I want to just do one other operation here. And that is sort page table by the spend reversed.
We'll see who's the biggest. Yeah.
Okay. Okay.
The political ammunition you could get by running these queries is insane.
Oh yeah. Now what did I?
What, did you get an error?
Yeah, I did. Did I misspell aggregate? Yep, I did. There is no aggregate method.
Not yet.
No, that's right. Aggregation is something completely different.
That would be a completely, fake news thing.
Okay, there we go. We have our top spenders. Okay, so on the issue of cost of living, the top spender is the Canadian Taxpayers Federation. They spent $35,000 so far this year, and that's gotten them like 5 million impressions. Pretty cool. So the way that we built this script, it's really easy for us to do sort of exploratory work. We can tweak our parameters, perhaps combine parameters, and remember that we can query for multiple search terms and multiple issues at the same time. Like we can, multiple countries and multiple search terms at the same time. Like there's a bunch of stuff that you can do playing with it. So what we've done in a little over an hour is we've built ourselves a tool that we can use to explore this API. And there's only one thing that's left to do in terms of like what I normally would do in this kind of exploratory work to make sure, hey, if I need to work with this again, I'm going to understand how to do it. And that is, let's create a chart. Okay. Let's create a nice little chart that will be something we can look at. We could also, if we wanted to, we could also send this out, because just like Petal has from methods that allow you to pull data out, it also has two methods, so you can see the different tools that we have to export data from Petal to different output formats. And in fact, to data frame, you can actually move data between pandas and Petal. So if you do have, like if you like pandas, but you have some high performance components of your data pipeline that you want to use Petal for, you can actually do that and move the data back and forth. Okay, but in our case, what we're going to do is we're just going to save the sorted table to a CSV, and we'll just call it spend-by-page.csv. Okay, cool. All right. And we can do one more Petal table, last one. Okay, just our top 10. Now let's make a pie chart of the top 10.
So in less than an hour, you've just given somebody ammunition either at a cocktail party or a parliament floor.
Yeah, now you're talking.
Holy.
Okay, so if we flip back to the top of the script, we aliased matplotlib.pyplot, okay, which is our interface to matplotlib, and we just aliased it PLT, okay, so that we can just call PLT instead of typing all that nonsense. So what's the first thing that we have to do? Let's give it a title. Okay. This is all pretty much out of the Matplotlib cookbook. Again, like with many technologies I use, I am not an expert. I am a user. So what we're doing here is defining the different subplots. Okay. And then if the near as I can figure out, the fig is the overall figure, and then AX is actually your actually chart, where you actually do the charting. So we're going to call it a pie, and we are going to use our sum spend column that we identified earlier, right? There we go. Okay, let's clean that all up. There we go. There we go. And we need to label it. There we go. Okay. Okay. So we've defined now what that's going to look like. And then we can save it as a PNG and close our plot. Okay. Let's see if that works. Trying to respect everybody's time, but I know I'm rushing through this a little bit. Here we go. Yeah. Okay. What did we do here?
More spelling.
Oh, just some extraneous parentheses. It happens. Okay. All right. Well, it looks like we've got a somebody who decided to use mathematical bold italic small for the name of their Facebook page. And they are your best at, well, we'll never know. Somebody had a bad idea. Okay, and where is our, there it is. Okay, there is our PNG. So it's not perfect. We've got your best something. We've got that guy with the characters that end up being like the empty boxes. You can see we've got some clipping happening where there's text that's getting cut off. So like we could tweak and refine our chart, but here's a pie chart that shows you who the top 10 spenders and their relationship between them in the Facebook ads graph. So what we've done today in an hour and 15 minutes is we started with creating your Facebook account, and we have concluded with getting a chart from the data. So this is a very, very fast drinking from the fire hose sort of tutorial. So I would imagine Lauren is going to post the video later on, and you can come back to our YouTube channel and visit this video as many times as you need to get what you want from it. And if you were on this call, I'm going to drop my email address in the chat. Okay. If you want a copy of the code, you can email me there. And that way, the folks who are watching this on YouTube later do not need to see that. I'm sure you folks are all trustworthy in YouTube land and wonderful, but you don't need to see that. Okay. And I see that there is a request for the F string in the chat, which makes a lot of sense. Sorry, Devin, I just saw that. There we go. There you go. Anybody get it working? No?
I was just following.
Okay. You will. I'm confident you will get it working, folks. Okay, that's that concludes our talk. I really sincerely appreciate you folks showing up and watching while I do my thing. And I really hope to see each of you at a future HackForge event and maybe presenting one yourself. Have a nice night,
Pretty
folks.
amazing, Doug. Thanks.